In this video, I want to have a look at areas of circular shapes. So to start with, we need to know how to find the area of a circle. So if we have a circle and it has a radius of r, then we can calculate the area by doing pi times the radius squared, so pi r squared. If we're given the diameter, which is the whole distance all the way from one side of the circle through the center to the other, we would have to halve it first to find the radius. We're also going to have a quick look at circumference as well and perimeter of circular shapes. So to find the circumference of a circle, we would do 2 times pi times the radius, or if we're given the diameter, we can just do pi times the diameter. So let's have a look at some examples. So our first example says for this circle, calculate to 2 decimal places its circumference and its area. So if we're looking at question A first, we're trying to find the circumference. Because we're already given the diameter, we may as well use this one. So pi times the diameter, so pi times 20. And if we put that in our calculator and round it off to 2 decimal places, we're going to get 62.83 centimeters as the distance around the outside of that circle. For question B, it asks us to find the area. So for the area, we do need the radius. So if the diameter is 20, the radius is going to be half of that. So half of 20 is 10 centimeters. And then to find the area, we're going to do pi times the radius squared, so pi times 10 squared. And when you put that in your calculator and round it to 2 decimal places, you'd have 314.16 centimeters squared. So we've looked at whole circles, but I wanted now to have a look when we've got fractions of circles. So in this one, we only have a sector. We actually have a quadrant because it's a quarter of a circle here. And we're trying to find its perimeter and its area. So if we have a look at its perimeter first, the perimeter is going to be this curved edge plus these 2 straight edges. So this curved edge, because this is a right angle here, this is a quarter of the whole circumference of the circle. Normally to find the circumference, we would do 2 times pi times the radius. Hang on, let's rewrite that. So we do 2 pi r. But because we only want a quarter of it, we're going to put a quarter in front of that. So we're going to do a quarter times 2 pi r. And then we need to add on these 2 lots of the radius on here as well. So when we plug those numbers in, we're going to have a quarter times 2 times pi times 3, because the radius was 3. And then we're going to add on 2 lots of 3 for the straight edges as well. So this first section is finding the curved edge, and this section is finding those 2 straight edges. Now when we put that in our calculator and round off, we would end up with we would end up with 10.7 meters as the perimeter of that shape. Now we also want to have a look at area, so for part 2. We know that the area of a whole circle is pi times the radius squared, but we only have a quarter of a circle, so we're going to put a quarter in front of that. So we're going to have a quarter times pi times 3 squared, which would give us about 7.1 meters squared, correct to 1 decimal place. Our next example is similar, but this time we don't have a quarter of a circle. So we need to figure out what fraction of a circle we do have. Now we know in a full revolution, there are 360 degrees. And in this sector of the circle, we only have 80 degrees. So the fraction of a circle that we have is 80 out of 360. Now you could simplify that fraction down, but you don't have to, so we're not going to bother in this one. All right, so first one, to find its perimeter. Now again, the circumference of a full circle would be 2 pi r, but we only want this fraction of that circumference to get that curved edge. And then we're going to add on 2 lots of the radius. So when we plug our numbers in, we're going to have 80 over 360 times 2 pi times 4.2 plus 2 times 4.2. And when we put all of that in your calculator, you're going to end up with 14.3 meters as the perimeter of that shape. Now to find the area, again, the normal area would be pi times the radius squared, but we only want this fraction of the circle, so we're going to do 80 over 360 to find that fraction of the area. So we're going to have 80 over 360 times pi times 4.2 squared, which is going to give us 12.3 meters squared as the area. In our last example, I want to calculate the area of this shape here. So this ring sort of shape is called an annulus, and it's made when you've got two circles that share the same center. So in this one, we're told that the small circle has a diameter of 12, and the large circle has a diameter of 30. So what we're going to do to find the area of this annulus, this ring, is we're going to find the area of the big circle and then subtract the area of the small circle. So we know if the diameter of that small circle is 12, then the radius of the small circle would be 6. If the diameter of the large circle is 30, then the radius of the big circle would be half of that, so 15. So to calculate the area, like I said, we're going to find the area of the large circle, which would be pi times 15 squared. And then we're going to subtract the area of the small circle, which would be pi times 6 squared. And if we pop all of that in our calculator, we're going to end up with 593.8 meters squared as the area of the annulus.